Okay, so let's talk about Scylla now and beyond. I'm Avi. I'm the CTO of ScyllaDB. Also did KVM back in the days. So let's start with Scylla today. It's acknowledged as a NoSQL performance leader, and we saw some examples in Glober's talk doing 1 billion rows per second on analytic scan. Also great at random access. It's also a great choice for low latency. A lot of our customers are using Scylla in challenging low latency workloads where they have to have SLAs, and not just on the average case, in the 99th and higher percentiles. And Scylla really is great with those kinds of things. And when you have to combine this high throughput and low latency, this is where Scylla really shines. This is something that only Scylla can do, give you millions of operations per second, and also gives them under bounded time. So Scylla is also great with high-density nodes. As you saw with node sprawl, data keeps increasing. We cannot combat that. More people are using services and generating more and more data. The data has a lot of value to you, so you want to keep more of it for longer periods. So the fact that data grows is a fact. And the way to combat the node sprawl is to make sure that every one of your nodes can store more and more data. And this is something that the hardware assists us with. So every year, SSDs are able to store more data. And now nodes that store 60 terabytes are commodity. And Scylla is a database that allows you to use those large nodes. And you do that without any compromise. So you're storing lots of data on the node while still delivering this great performance, still delivering great latency, and node recovery. So if a node goes down or if you need to start a new node, it's still, you're still getting the same performance that you're used to with a lower density node that you had before. And this is shipping now. We're also leading in combined OLTP and online analytics processing. And we have several features that allow us to do that. So the first is workload prioritization. There's, by the way, a great demo outside, so I recommend you go and watch it later. And workload prioritization allows you to dedicate resources from your servers to different workloads in your business. And these are all shared and managed by Scylla using our schedulers. So you can say that you're dedicating 20% of your resources for analytics and 80% for online, and Scylla will manage those resources for you. And this allows you to avoid having different silos for online and analytics. We can control the cache and say which operations use the cache and which operations bypass them. You don't want your analytics workloads swamping the cache and reducing the efficiency of your OLTP workloads. And this way you can eliminate those data warehouses instead of having a database for every different type of operation you want to do and have all of the complexity of shipping the data from one database to another via perhaps a third-party streaming interface. Instead of that, you have everything in one place and you perform all of your operations there without moving the data around. And we have multiple ship vehicles. So open source, this is great for the early adopters. If you have those less critical workloads that you can live without support. And it's good to experiment with the new features. It's also great if you're comfortable with supporting yourself. Scylla Enterprise is the way for the really mission-critical workloads. It comes with long life cycles. It comes with the great support that Glober and the rest of the support team provides. And it comes with enterprise-specific features that are needed for regularity purposes or other reasons. And lastly, there is Scylla Cloud, which is the easiest way to consume Scylla. You take a hands-off approach. You don't need to touch any servers. You don't need to provision anything. You just let us do everything for you. So looking ahead. So one thing that's good to do is when you have something, one of your strong points is to double down on it and make it even stronger. So increase the lead. And one area where we're doing that is in high density support. And we have our incremental compaction strategy. And the way that this works is by splitting SS tables into smaller fragments, about 1 gigabyte in size. And what this allows you is while you're compacting a bunch of SS tables together, instead of waiting until the compaction completes before you delete the source SS tables, you can start deleting the fragments as the compaction progresses. And this means that while you're generating new data and laying it down on disk, you start removing the old data concurrently. And this means that you need less temporary storage, and you can see it in this graph and also in the talk that we will have in the summit about it. So this can save you a lot in terms of extra storage that you can either not buy in the first place, or perhaps use that to increase the density, increase the amount of live data that you're storing per node. So more enterprise features. We already have encryption at rest and authentication, but we're increasing the breadth of that offering. So we have support for KMIP, which is the ability to store keys outside the server for increased security. And we have more authentication options. You can use LDAP to manage your users and to manage the permissions that you grant them. And we're increasing our OLTP and OLAP integration. And Dor also talked about that, and I will also talk about it tomorrow in my talk about this. We're increasing the number of things that you can do with your data while it's still on the server. So instead of pulling it out of the server, you can do some of the transformation and some of the filtering within the server, and you can, by having a user-defined function, you can customize it. And we will increase that even more by allowing you to do transformations over the data within the server. So the ability to create temporary tables that are transformations of your existing data and apply a sort of pipeline to do those transformations one after the other with high efficiency and high throughput. So we'll also be working to expand the types of services we can provide with Scylla. So of course, we started with Cassandra. And that's already 2 protocols. There is a Cassandra native protocol and Thrift, which was the older Cassandra protocol. But now we are also adding support for 2 more protocols. The first is the DynamoDB API. We're adding compatibility with that. So that makes it easier for people who started. Everyone knows how easy it is to start with the cloud. They even give you the first hit is for free. And then it's very easy to increase your footprint until you get the surprise at the end of the month, the $10 million problem. And by supplying a compatible API, we make it easy for users and customers to move their workload and reduce their spend without changing their applications. Another API that we're building is Redis compatibility. And Redis is a very popular API. It allows you to do a lot of things with your data. It's very flexible, but it's also in memory. And that means that it's quite expensive. Memory is about $10 a gigabyte, while disk is perhaps $0.50 per gigabyte. And by moving your application from Redis to Scylla, you can reduce your memory cost by a factor of 20. And because Scylla provides great performance, then your application will work as it did before. So we're providing more consistency options. We started with eventual consistency. And eventual consistency is great in terms of availability. A node can go down, and you will not notice it. It provides a great throughput. But there are some applications that don't work well with it. So we're providing more consistency options. So we'll provide 2 flavors of transactions. The first is the Paxos style of lightweight transactions, and that gives you more guarantees about the consistency of the data, and especially with the read, modify, write operations. And Paxos gives similar greater guarantees, and with similar high availability. So a node can go down, and you will not even notice because it keeps going as before. We will also provide a second version of lightweight transactions using Raft. And this gives you a higher throughput than Paxos. It can be significantly higher. But you're trading off something. And you're trading off the high availability. Of course, it's still highly available, but you will see a drop in performance when a node goes down until the system can recover. So you will have a choice between throughput and the amount of temporary downtime that you have when a node goes down. Change data capture. So like Thor said, we spent a lot of effort into making sure that this API is easy to consume. And it works, it appears just like a regular table. So you insert into your base table, you insert your values, and your changes appear in a different table concurrently, and they're now ordered by time, and you can consume them. And because they're regular tables, you use the regular SQL operations, you use the regular SQL drivers, you don't need to retool your system, you don't need to learn a new language, and all of the other features that we work with, like UDF filtering and aggregations, they also all work with CDC as well. So it's good to build features that work well with each other. They become a power multiplier. So change data capture, it's used for, there are mainly two major use cases for it. One of them is to synchronize different databases. I mentioned before that with our analytics support, you might not need to synchronize multiple databases because you can do a lot of things with Scylla, but sometimes that's not what you want. Perhaps you have different use cases. So we provide the ability to export the data to other consumers. And also for online analytics, like fraud detection, this is a primary example, where you want to analyze things as they happen instead of passively they are stored in the database, which is the usual analytics style. And change data capture gives you everything you need to do that. So of course, the change is the deltas between the row before the change and after the change. And we also provide you a pre-image and post-image, which gives you the state of the data as it was before the change was applied and after. And this gives you all the tools you need to do your analytics. So we think that Scylla is ideally placed for microservices. Is anybody here using microservices? Can I see some hands? 1, 2, 3, 89 million. Maybe some people voted more than once. OK, so people said that serverless means that you're running on someone else's servers. And in the same way, stateless microservices means that you're storing your state on somebody else's database. And we're building Scylla so we can be that database. And microservices increase the demands from the database. You have lots of microservices. You have those popular images that show companies have tens of thousands of microservices, and they're all interconnected. And because they don't store any state, each new microservice places a new load on the database. And that means that your database has to have high throughput. Also, when you have a lot of microservices, then the end user time, each request becomes broken down into lots of little requests that each go into a different microservice. And the overall latency is now composed of all of the latencies of all of those microservices requests. So keeping the latency under control becomes even more critical than ever because you're adding up all of those latencies. So having a database that supports this low latency is critical as you're increasing the number of microservices. And Workload prioritization allows you to devote resources of the database to the important things. So if you have some things that are serving, that are user-facing, you can devote more resources to them. The services that are not doing the critical things, or maybe things that are not time-critical, you can devote fewer resources to them, and they can take up the slack, use the idle time. And by having the database do that, you can keep your own team focused on their task instead of trying to manage all of the resources and trying to play with priorities. So you can just let the database do this management. And now talking all that much about microservices makes me feel like a dinosaur because I'm building a monolith. But someone has to do it. Speaking of keeping your team focused, so Scylla Manager is another thing that we're building, and that reduces the administrative burden. It's part of our enterprise offering. So we're adding more and more features to reduce things that you need to do and automate them away. And of course, if we talk management, then Kubernetes is also a hot topic. So traditionally, doing Kubernetes is great for stateless applications. You can just kill a pod and start more pods without giving it a second thought, and Kubernetes will do everything for you. For stateless applications, it's harder. You want your pods to remain in the same place so they can keep accessing your data, your state. And starting a new node is a more complex operations. You need to stream the data, and it only becomes active once the data is streamed. So we're building a Scylla operator in order to bridge that gap so that it can give you the goodness of Kubernetes without falling into the pitfalls that stateful applications have with Kubernetes. So let's look at our release roadmap. I'm not going to read it to you, but we are working hard to deliver those new features as soon as we can with different timelines. So we have one timeline for our open source releases, another timeline for enterprise releases, and a timeline for the cloud, and of course the Scylla Manager. All right, so that's it for me. Let's stay in touch. On my Twitter account, I sometimes live tweet commits as they get merged. So if that's your thing, you can follow. And I get very little email, so you can drop me a line, and maybe I'll see it one day. Thank you.